Yeah, this one is the right one. Uh, yeah, I'm audible and I think it's visible to everyone.
Yeah, yeah, everything
Yeah,
looks fine.
yeah, I will start them. So, uh, so good morning to everyone and thank you for introducing me. I would like to thank that Air funded online workshop, the organizers, particularly the Arul. And my today's topic is from ocean to the package, exploring the seaweed-based intelligent solutions. So here in today's case, we are going to have some backgrounds about the seaweed, then understandings of the seaweeds like their classifications, the most important one, the seaweed-based polysaccharides, then how we can explore these seaweed-based polysaccharides to prepare these intelligent packaging and the challenges and the future prospects. So basically, here our ultimate aim is that how we can explore, how we can harvest all the possibilities from the seaweed-based polysaccharides or the packaging, the aids to have some intelligent solutions in terms of the intelligent packaging. So let's start. So background, just from yesterday's, the most eminent scientists, they have discussed the very good presentations. And here I'm not going to that much emphasize, but as we know that the seaweed is this, the marine microalgae, and it is having the multicellular photosynthetic organisms and found in the aquatic regions. But to some of these slides, I will say that it is the most promising resource with the having all the capabilities to harvest into these packaging materials. It is also being crowned as a millennium plant, having the social, economic, and the environmental benefit. Okay, the classifications, though I'm not going to discuss that much, but the seaweeds are being, as we already knows, the classified on the basis of their the color, particularly the brown seaweeds, the red seaweeds, and the green seaweeds. And there are like various species, and the red seaweeds are dominating in the overall seaweed populations, I would say. Okay, coming to the packaging one, as the trend has been shifted from that plastic packaging toward the this eco-friendly food packaging. That food packaging should be biodegradable, should be recyclable, should be compostable, and the consumers demand this type of packaging nowadays. On that basis, here we can see the global statistics, and this market size is increasing by year. And as the predicted, there will be like 6.5% cumulative annual growth rate can found from 2023 to 2032. So this much huge potential is there in this eco-friendly food packaging. And here in this chart, you can see this biodegradable packaging. They are like playing the bigger role. There are like more than 42.2% of these biodegradable packaging are playing the role in this eco-friendly packaging particularly. Okay, now coming to this eco-friendly packaging, we have seen that yeah, they are playing the very good role. It's the huge demand, but in terms of these, the main source of these biopolymers or these eco-friendly polymers are the plants and the marine organism, and in which particularly the seaweed is playing a very good role because these are, I think, very rich into the antioxidants, the fibers, the polysaccharides, and they are the strong and the resilient one. So these seaweed-based biodegradable polymers offer a sustainable and a superior advantage to packaging material compared to the conventional ones. It includes other biopolymers also. So the major advantages of the seaweed-based packaging material is that they can be made edible without use of any uh, external agents or the preservatives we doesn't need to add into them. Okay. So the sustainability again we'll discuss the how it is more sustainable one. So they are the biodegradable, as we already discussed. They are like 100% biodegradables because they are made from these natures. Then the reduce the plastic pollutions. So by implicating or by producing the of food packaging, we can easily target that the plastic pollutions. We can easily reduce that one. Versatility here, the different type of packaging materials, maybe the coating, maybe the smart packagings, or we can easily form from this type of seaweed-based polysaccharides. Then the potential health benefits, as these are the seaweed-based materials, are rich into the vitamins, the antioxidants, the omegas, everything is quite very in a good proportion. Although here I'm discussing this point in terms of this edible packaging. If we are going into that size, so it is of good source and it is rich source of the protein, very less fat, and it's a good. Then safety one, there are like very minor traces of any elements, but still they are excelling into the safer side. And the renewable source, there is that AdLab source of this seaweed is available. Uh, the important polysaccharides, there are like many, but these the which I have mentioned in the table are the polysaccharides which are increasing their demand year by year, and they are playing the great role for these food packaging materials like the alginate, cellulose, the carginol, the starch, the one like this. So we are going to discuss among we are going to pick one polysaccharides. We are going to make intelligent one. So let's move. Okay, so types of seaweed, there are polymers as in the tables. I have shown the different one. But the promising one, like the alginate, it's a linear polysaccharide extracted from the brown seaweed, known for its excellent gelling properties, biocompatibility. It can be used into the food or the pharmaceutical, biomedical application. Apart from these, it is being commonly used, or nowadays there are many research are focusing to form these the food materials or the food packaging materials, I would say. Then this carginol, from the red seaweed and used as a thickening, the gelling agent in the food products. The previous speakers, they have highlighted the role of these the seaweed-based materials into the food, how we can use them. And the most important one, these carrageenol or the alginate are having very good film forming properties and can be explored for this food packaging material, pharmaceuticals, cosmetics. Coming to the agar, they are like the gelatinous substances extracted from the red seaweed, and they are also being used at the various microbiological type of works. And these fucadum, they are sulfated polysaccharides found into the brown seaweed and studied for this potential health benefits. So these are some biopolymers, and here we can proceed to form these films, the food packaging films from these type of seaweed. Uh, so there might be the questions why these seaweeds, there are polymers only. There are the good reasons for we have the first one is these antimicrobials and the antioxidant properties, because the seaweed itself is a rich source of the different phenols, the terpenes, the actinins, the arols, and many more antimicrobial agents. And they are also having these antioxidant agents. So here, the one important point we need to know that they are having these good properties. If you are going to choose them as a biopolymers for the film forming or the food packaging materials, composite adaptability here, like they can admix with the polymers, the additives, maybe the active one, maybe the antigelent component one, or if you want to form a composite film also. The seaweed-based biopolymers have this adaptability, and they will admix easily with these different types of added agents, I will say. Then the desired mechanical properties, because in case of film forming, we need some the packaging material. It should have the tensile strength, should have some flexibilities, and for these type properties, the seaweed is doing their best. The seaweed-based derived these polymers are doing their best. The physical properties, the structures, the surface, the homogeneous mixture, as we have discussed, that's why they are also improves these physical properties of the film forming, and the chemical characteristics in terms of these film hydrophobicity, because if you are going to use these biopolymers for the formation of this packaging material, so here the hydrophobicity the water contact angle, the intermolecular chemical bondings, the water vapor permeability, oxygen transmission. So these the parameters, the chemical characteristics of the resultant films are found at a very good rate, I will say. Then the thermal properties, as compared to these commercial one, it is although at lower side, because in most of these biopolymers, apart from the seaweed, also the thermal properties are the issues. But still, the seaweed-derived biopolymers are doing their best. So these are some properties which we can harvest to prepare this food packaging material. Okay, so up to these previous slides, we got the understanding that the seaweed-based biopolymers are the best, or the research findings which are being carried out till that are shown that these can be explored to form something new. And to achieve that one, my topic I will say started from here only. So the coming slides that work I have carried out at the Kungi University under the guidance of Professor Rim. And there we have prepared one intelligent films, or the intelligent indicator films, I will say. And the base material we have choose is the carginol. Before selecting this carginol, we done some preliminary trials. So what we found that these seaweed-based carriageron are doing their best, and we can proceed for that. And after that, we selected the carriageron as a base material, and we try to add some active as well as intelligent agents into that carriageron, and we prepare one indicator films. So let's start that journey here. Uh, just some introductions. The smart packaging, we already know. Smart packaging is the packaging which have the capabilities to act as active as well as to act as intelligent one. So active one that will retard the growth of microbes, that will stop the growth of microbes. They will stop the oxidation, particularly in case of livestock products like this meat, the fish. They are having a more oxidation rate. So these active ingredients they will stop that processes. The intelligent one will sense the inside material, and they will give us some real-time idea about that inside food or that environment. So that comprises of the smart packaging. uh, as we have seen, these seaweed-based biopolymers will definitely open a new era with their functionality and desire for the packaging application, as we have discussed already. So these intelligent packaging, the packaging which can have the capabilities like the detecting, sensing, recording, tracing, communicating, and applying the scientific logic to facilitate the decision about the shelf life, safety, and quality of the packaged food. So based on these all materials, we selected the halochromic indicator. So these halochromic indicators are these pH sensor. I will say the pH sensitive sensors are the group of indicators. There are many, but these are based on the pH, and they will change their color with the change in the pH. So these calorimetric pH indicators can be integrated into the food packaging materials to monitor the changes of the food, basically their acidiness or the basic components, leading to act as an halochromic or the pH sensitive sensor. So in view of these discussions, we plan our research with the objectives to develop this halochromic carrageenan-based intelligent biodegradable film indicator for quality monitoring of livestock products. And these were the broader methodology. In the next slides, I'm going to discuss the proper one. But here, as the topic should not restrict with the carrageenan only, but how we can proceed for intelligent way, the intelligent solution that I have depicted in this slide. Like what we have taken, what we have studied, that because there are like these anthocyanin indicators, we can how these indicators as the halochromic indicators, they will change the color as per the change in the pH. Then we have selected the active agents like the carbon quantum dots. So So nowadays, there are many research going on these carbon quantum dots, and the carbon quantum dot, the sulfur quantum dots, they are the future of the coming, what I will say, the packaging industries also. And here, for this presentation only, we do need to understand that we have used these carbon quantum dots as an active ingredients or the active agent. So the first, we have selected the anthocyanins. We have collected them from the fruits or flowers. And the second, the active agent, we have selected the secretives. Now the next challenge where we can have a base. And here we choose these seaweed based biopolymers like the carrageenone we have selected. And on that basis, we have formed a packaging film solutions. After casting, we have developed these holochromic intelligent biodegradable indicator films. Uh, Coming to the main research that what we did actually by using this carrageenone one. So the topic that the title we already discussed here, the carbon dots, the anthocyanins, and the carrageenone. To have the anthocyanin, as I've said, we can use the different flowers, maybe the fruits, the leaves we can use. Here in this experiment, we have used these red rose flowers. It's the rich source of anthocyanin, and it is a very good, promising anthocyanins, having very good characteristic as compared to these the earlier studied one. We do have choose that red rose flowers. So here in this chart, we can see that the first one is these rose petal anthocyanin. Here the flow chart. I'm not going into that detail, but by using these red rose flowers, we do have prepared this rose petal anthocyanin, and in the upper chart here you can see we do have prepared these rose petal carbon dots. The carbon dots are the nano carbon dots. They are having the less than 10 nanometer size, and they are very good active ingredients, can be used safely. I will say the safely word over here. There are some toxicology studies we also have carried out, and we found that the carbon dots which we have prepared from these red rose flowers are safe to use into that packaging material. So the 5% rows of petal anthocyanin, 2% of these carbon dots, these are being used for as active as well as the intelligent ingredients, and these are being fixed on this carrageenone-based film. And these films acts as an indicator carriers as well as the symbolizer. And we proceed some analysis. So there are some results. I'm going to discuss that results. So when the films are being formed, these RP series are these carbon dots, the carrageenone, the carbon dots, and the anthocyanin added films, and the neat carrageenone films. So what we have found that these both the added ingredients, they have very good surface interactions with this carrageenone, and they perform their role in a very good manner, and a very the output, the results are a very good one. Here, the different surface interaction, the different the chemical reactions, the vibrations, the stretchings. Here we can see these are being carried out by using the FTR. Then coming to the next, the SEM analysis, the scanning electron microscopy, the thermogravimetric analysis. We do have done that, and here we found that the carrageenone films, when they are being added with these carbon dots as well as with these anthocyanins, they do found very in a gooder manner. They are having the uniform matrix, the denser cross-sectional surfaces, and the uniformity. These added ingredients are being distributed uniformly into that film. Again, in case of this TG analysis, we found that there is an improvements in this stability of that particular film. So here we can conclude that the carrageenone, when added with these active as well as intelligent ingredients, they are doing their best in terms of the same as well as in terms of their thermogravimetric analysis. Coming to the next, the film characteristics. The thickness, the tensile strength, the elongation at break, these are the different parameters. The physical chemical one, they found like found that these are being improved. Then these the films the which we are they are formed, they are the hydrophilic films. There is an increase in this hydrophobicity. The good cross linkings we found and the enhanced the cross net effects in these car films and the increased UV shielding. UV shielding has been found to be increased. The reason might be that carbon dots, because carbon dots are very good UV blocker. So these were the finding for that. Then okay, we are quite interested into these points. The intelligent one. These films are being subjected for this in vitro halochromic evolution. The in vitro evolution, these are being carried out by using this ammonia and these acetic acid. So the particularly the acetic acids are being used as on the acid side, whereas the ammonia is being toward the base side. The form film, after adding the anthocyanin, the carbon dots, we subjected these films and we exposed these films to the ammonia as well as to the acetic acid. What we found is that when we do expose to the acetic acid, the color of that film has been changed towards that redder side. If it is the ammonia, then it like it was toward this yellowish side. So and the here the first photographs we can see that it is the no exposure film, and by exposing to that in vitro model, these films are doing their best. And here we can conclude that our films can be applied to in vivo analysis. So after that, we followed the in vivo full model system because in vitro we got a very good results. But now we need to test whether our developed carrageenol based intelligent films will work with in vivo or not. So what we done is that we use the mean spoke as well as the shrimp, and we pack them into the boxes. And inside to that box, we fix these indicator films inside to that, and these boxes are being stored for 48 hours at the room temperature, particularly near about 25 degrees Celsius. The inside materials are being subjected for the pH, the extracted volumes, the total color change, the consumer sensory scores. We do have done that sensory analysis by using the different consumers in terms of overall acceptability. And here we try to comprehend these complexities of in vivo food storage indices using these color properties of the indicator film. So these parameters, we try to collaborate with this indicator, the color of that indicator film. As we know that when any the high fat or high protein foods are being stored for a longer time, so ultimately there is an increase into the pH, and that the thing we have tried to monitor by using that indicator, and what we have seen that here, in this photograph, you can see these are the reference one, and here these yellow are our indicator films that are being directly exposed to the internal environment, and the shrimps as well as this pork. After 48 hours, they got spoiled, and our films, the intelligent films, they responded in a very good and a very best manner into that one. Here we can see this chart, like the pH, it is increasing here up to the more than like 5 up toward that side. Then this ERV is also decreasing. This ERV is nothing but this extracted release volume. Instead of doing, it is the quicker method to have these the quality testing of that particular the food. And this overall acceptability, we also found that it is decreasing as per the storage period progress and overall change in the color. So here in this slide, I would like to say that these the developed indicator films, they have predicted valid time the spoilage inside that food. Uh, as I said, the colors change from red to the yellowishness. The B values, these are these color indices showing the higher B values as compared to the at the start, and the observed color variation indicate that the newly produced indicator films exhibited an intelligent behavior by accurately detecting and responding quality shifts in the store food in real time. So these are some theories behind this color change, particularly to that the anthocyanin, that color are being changed. So we can see that due to this enzymatic degradation, there is an increase in the pH, and the anthocyanins are rich into different base materials like this carbinol, the calophenol, then this sphingolidal. So they comprises they are playing their role to change that anthocyanin will change into maybe the colorless less or maybe the yellowish. So at the end of this particular research, we concluded that the rose petal anthocyanin at the 5%, the series at 2%, these are being added into the carrageenan-based films, and they improve these film properties in the thermal stabilities. And here, these carrageenan film, they can their functional as well as their mechanical properties has been improved significantly. In the in vivo model, they develop smart packaging films. They identify or they monitor this freshness in real time, and these anthocyanin carrageenan-based nanocomposite films that added with these carbon dots have a good potential in a food packaging application, especially into the new active and intelligent packaging with the multifunctional way and promoting the significant development in the smart packaging. Now I'm coming to the challenges and opportunities into this type of works or the intelligent to form this intelligent packaging, particularly from the seaweeds. As we know that the seaweeds have the capabilities to be used as a base material to form these intelligent as well as the active packaging film. But still, the research in this area is at very earlier stage, and we need to focus the more in-depth research in this way. And there are some challenges like these enhancing the performance because
Dr. Rajesh, sorry, just
yeah,
being mindful of the time. If you could wrap up in the following minutes, it would be great.
yeah.
Thank you.
So the performance, we need to give the attention to enhance the performance of these seaweed-based polysaccharides. Then the legal aspects, there are these legal aspects and the regulations are in overall for this intelligent one, or I will say this seaweed packaging are not up to the that mark. We need to focus on that legal aspects and lack to market. The most of these research toward, like I will say, the intelligent one or the active one are limited to the laboratory, and we need to harvest this result into the market. So here my concluding side, my concluding remark will be like that. It is the seaweed-based polysaccharides or the biopolymers are the futures of the food packaging. They are like the environment friendly, ideal for the applications. The research need to be focused on optimizing the process so that we can easily have some good results as compared to that competitor one. The more detailed research should go into the specific fields in which the sea would have the biggest advantages or this common packaging. And in the future, the development of the seaweed smart packaging can serve as a valuable tool for research markets and as well as to the consumers. So thank you, everyone. These are my contact information. If anyone have some doubts or may be something, they can contact me. Yeah. Thank you.
Perfect. Thank you so much for your presentation and showing us all this great work.